Hello, can you hear me? Hello, hello. Yes, if you can hear me, that's fine. Now we will start our lesson, inshallah. Well, now let's start our lesson today. Yesterday we have done and we have finished the example 5.5. Example 5.5 and solution also, of course, is given in the slide. But we also solved. Now we will start new topic today. Okay. Are you hearing me? Yes. So the exam will get within 2 weeks. All right. So today we will start, inshallah, hopefully new topic today. So 2 or 3 force member. Now today is this 2 and 3 force member. What is this? Right. First we start two force member. What is this? When forces are applied at only 2 points on a member. Member means something on what load is applied is called member. Like yesterday we did the beam, it's also kind of member, right? Now if load is applied only 2 point, the member is called 2 force member. But there is something I need to add. I will add you the 2 force member, and the force will be opposite to each other, and force will be equal magnitude, and force will be collinear. So something is written, I think it is written there, I don't know. Okay, 2 force member, right? Here only mention that the one member, like as an example, in a crane, you find this kind of thing. Okay, here one joint and here another joint. When the crane shaft move, the force is work only point A and point B. An example here, point A and point B. But there is some properties. One is the equal force. Force is equal. Okay, equal force. Two is force is opposite. And three is collinear. Right? Collinear. Now for 2 force member, what is 2 force member is will be, you see, the force will be equal magnitude, force will be collinear, and force will be two opposite direction. Then we will say this is the 2 force member. And another one is 3 force member, right? 3 force member. 3 force member. When subject to the 3 force, the forces are concurrent to, like if the member has 3 force and 3 force, like here example, one side meet some point, then we will say it is 3 force member. As example here one member, so one force here, and one force here. Now you see the line of action of force will meet some point. one point, then it means it's called 3/4 member, or the force will be parallel. Force will be parallel, then it's called 3/4 member. Okay, it's called 3/4 member. So we learn what simple thing. So we learn what 2/4 member and 3/4 member. Now, what is this? This is a small thing, but we will learn now one example applying these two things, 2/4 member and 3/4 member. That is the application. Next example. Okay. Now we will start one example using 2/4 member, 3/4 member. But as example, you see here. Example is, it should be go there. Lever. What is lever? Lead in there. Lever ABC. Lever ABC. So here A, where is A? A, B, and C is pin supported. That means it is pin or hinge. We learned before. We told you before. Pinned is like this picture. Okay, picture. So pinned or hinge. Pin or hinge. So is a pin supported at A and connected to the short link BD. Short link. This is called link. One link connected to short link BD. And here is the pin. Here also pin, and B also pin. So D also pin actually. Weight of the member are negligible. So that means saying the member weight we neglect. Not given, so we neglect. Determine the force of the pin on lever A. At pin, a reaction force is need to determine, right? You understand the question? Did you understand the question? Tell me please. Did you understand the question? No. Thanks. At least you said no. Very simple. You see the picture. If you don't know, it's no problem. A picture. So some kind of the structural member, and it is its hand. It is pulling with 400 Newton load. 400 Newton load. Okay. A is pin joint. B is pin joint. B also pin joint. Now question is, what is the force at A? Reaction force. Reaction force at A. RA. RA or FA, whatever you want to write. FA. Now clear? Abdullah Muhammad bin Abdullah. Clear? So you have to find what is FA. That's it. That's it, right? That is our question. Only that is our question. Now the question is simple, that now the problem here now again. So this is one member. This is one member. ABC. Lever ABC is a one member. Okay. And lever and link BD is another one. So BD is another one. BD. So this is BD. Okay. So BD is one part of it. BD is one part of it. Here is the pin joint. Here is the pin joint. And ABC also another part of it. And now what I'm telling, is that clear? Tell me. And here it is 400 Newton. 400 Newton force is applying. Here is A. Point A. Right? Now we have to find out this is RA or RB. Okay. Now we just learned 2/4 member. We just learned 2/4 member. Okay. You know the here is another point. This is B. This is C. Okay. Now look at to the BD. The link BD link or BD member, whatever you give name, no problem. Or member, BD member. Look it looks like this. It looks like this. Only two two forces only. Our diagram is like this. Only 2 points we have. Only 2 points we have. So similarly, we will have only two forces will be working. Two forces will be working. How it is working? We connect this force and then force. So one force will be FB, FB, and another force will be FD at the point D. But it is the two force member, we know this FBD and FB and D will be equal. FB and D will be equal. And then the angle here is 45 degree. Angle here is 45 degree. Why? Because this is point 2, this is point 2, this is point 2, and this is also point 2. So if you calculate, the angle will be 45 degree. Do you understand up to this? You need to respond me. You need to respond me, right? Tell me, you are clear up to this?
Yes, doctor.
Yes, fine. You have to tell me because I am doing step by step. First, this is the two. We have two separate member, joint member. One is BD and is ABC. Now this was the two members. So two member we separated it. After we separate, we found the BD actually it is a two force member because only two joint we have. So if B force B work in that direction, so we simply it will be one line collinear, and BD will be opposite direction. Why opposite? Because for equilibrium, right? In free body diagram we learn it. That if it is the positive, if it is the upward direction, so for balancing, for equilibrium, D will be opposite direction. Okay. We don't know the value. Now see the joint B is jointed here. That means here. So if it is the positive direction here, upward direction, at B it will be actually downward direction. Why? For the balancing. When we make separate this point, so if it is this direction, so it will be opposite direction. But as I told you before, when your force and direction is the unknown, you can draw anything. You learn just last class. If you assume the FB is this direction, if FB is this direction, so FD will be opposite direction. FD will be opposite direction, in this direction. In this case, the joint B for this member, joint B, the force will be then what direction? Force will be opposite direction. If it is the downward, that means it will be upward direction. Okay? Because to make it balanced, to make it equilibrium. Now in example, in here we assume this upward. You can assume anything, upward or downward, doesn't matter. Upward or downward doesn't matter. But at the end, we learned last class a basic thing that if your assumption is correct, then result will be positive. If it is not, then result will be negative. If it is negative, then we have to change. So we learned the yesterday example last class. So here we assume it is upward. If it is the upward, we assume the force is working in upward direction. If it is force upward direction, then this will be downward direction. Okay, this will be downward direction. Now we have the point A, point reaction, point C. We have already applied force. Point B, we got now we assume the direction FD. Now we have remaining point A. Now you tell me, what is the support type of the point A? Someone tell me. Support type, we learned three type, right? Roller, hinge, and roller, hinge or pin, and fixed support, right? Hinge support. Thank you. Hussain said hinge support. And now next question, if it is hinge, how many reaction will be there? How many reaction? Tell me. Two reaction, horizontal and vertical, right? Horizontal and vertical. Again, horizontal and vertical, we can assume our reaction, horizontal reaction in this side or in this side, whatever. We can assume our vertical reaction this side or this side, whatever we want, right? So it is up to you choice. You choose whatever you like. Whatever you like. Okay. Now, uh, you can assume whatever you like. Okay. It is up to you. As I told you before, if after the calculation you find the result is positive, that means your assumption is correct. If result is negative, that means your assumption was wrong. But no problem. Don't worry. Just change the direction. Okay. Just change the direction. Now here we assume I keep this one. I assume the horizontal direction is to the right side and vertical direction is upside, right? Now tell me one thing. If I assume like this, suppose I write down this is R A H, and this is R A B. Okay. Now resultant force of these two will be like this or like this. Tell me, upward or downward? Tell me. Up, right? Fine, up. If it is up, so I read you. If it is up, so I write down. I move it, right? Now, if it is up, so we can write down. It is RA. It is actually RA. If we want to work with RA, so we can delete this one. We can delete this one. Okay, because RA is the resultant force. It contain both horizontal and vertical. It contain both. So now we will just keep the resultant force of our horizontal vertical component, right? We will keep the resultant force or horizontal vertical. So we just assume that RA is like this, upward. RA is upward. Right? Now you see how many force we have here. Tell me, Abdullah Muhammad or Ali Jawad. Tell me how many force we have here in member ABC. Why 2? I see 3. The 400, FD, and yes, RA. Now we just learned 3. We just learned 3 force member. We just learned here, right? 3 force member. If our several force, 3 force, somewhere coincide, then it is 3 force member. Let's see our cases. Our case, what happening? Let's see. Like if we extend this line here, and this line, so it coincides some point. Suppose point name, we give the name O. Give a no. Oh, so BD was 2 force member. BD was 2 force member. 2 force member BD. But ABC is 3 force member. 3 force member. Now how can we solve our problem? This is the thing. So we found here it will consider there. Now here if it is there, now tell me what will be the angle here. Can you tell me this angle? Suppose this angle is theta. Can you tell me what will be this angle at B, at point B? I need to draw it more clearly. I will draw it more clearly now. But you have to tell me the clear answer. You have to tell me the clear answer. 45 degree. Thank you. Yes, correct answer. 45. Correct answer. You told me the correct answer. I draw a new I take a new slide, so because I need some empty space. Okay, so I draw it again for you. So you said you have the like this ABC member, right? And here you have 400 kilonewton force. 400 Newton force is working. 400 at B. You have you have what at B? At A. At A you have RA. So I need to draw it more clearly. I will draw it and tell you. RB, B, this is FB, and this is RA, right? So now they are which it is the 2/4 member of 3/4 member, right? This is the RA. So it coincides here, okay? And you said that this will be 45-degree angle, 45-degree angle, right? Your answer is correct. Why 45-degree angle? Because our this was 45-degree angle, right? So if this one 45-degree angle, so this one also 45-degree angle. So our this angle 45-degree angle, and that's why your answer is correct. Your answer is correct. Now we go back for dimension. For dimension, we need to know the dimension, and I tell you the let's see the what is the dimension here, right? What is the dimension? From point B to point B to C, our dimension is 0.5, right? 0.5. So let's go from B to C. From B to C, our dimension is, this is the point B and this is point C. Our dimension is 0.5. 0.5. What is 0.5 meter, right? 0.5 meter. Now, if it is the 0.5 meter and here is 45-degree, now you tell me what is the distance between the C and O? Tell me. Okay. What is the distance between C O? Calculate and tell me quickly. The distance is given here. Here you have 0.5 and angle is given 0.45, right? So what is this angle? Same. We're saying same. Okay, fine. This is also correct answer, right? So I directly write down 0.5 meter. 0.5 meter. Okay. Now you're going to tell me now what is the angle between, we have some more dimension. You see, from B to A, from B to A, our dimension is 0.2, right? And B to A, sorry, B to D is 0.2 and A to B is 0.1. So we write down those dimension because we need them. So here this was B and here A, right? So here the direction is 0.2 meter. 0.2 meter is our distance, and A to B this distance is 1 meter. 1 meter. We know this direction, right? Now things is we need to know something else. We need to know something else. I draw it by blue color. So if I draw it here like this line and this line, so this angle, we have a angle, right? And the angle, just I give name theta. I give this name is theta. All right. This name is theta. 0.1. This is 0.1. This is actually 0.1, right? If it is this theta, so what is the angle theta? Can you calculate please for me? Theta. Tell me what is the theta equal to? Tan inverse. Tell me. Because here you have 0.5. I do it for you. Here it 0.5 distance, and from here to here is 0.2 because 0.2, right? And here to here is distance is 0.4 meter because here to here is 0.5, and if it is from here to here is 0.5, so here to here is 0.1 and 0.4, right? So what is the theta angle? Tell me please. 60.3. Yes, result is correct. 60.3. 0.7, 0.74 and 0.4, so you will get 60.3. The angle theta is 60.3. Fine. 60.3. Now 60.3. Why we are doing this? Now if we draw the fresh diagram like this, we draw the fresh diagram. Okay, so here what we have, 400 Newton. Here we have at 45-degree angle, FD B, and here we have RA, or you can write down FA, doesn't matter in this case. And angle is here angle is 45 degree and here angle is 60.3 degree, right? So this is what we have. And distance, what distance we have? We have the distance. We need distance later on. We need distance. The distance is here to here 0.5, here to here 0.5, here to here 0.5, okay, and here to here 0.2, 0.2, and here to here 0.1. You already know this distance, 0.1, 0.1, and here to here is here is 0.4 meter, right? 0.4 meter. Now we have how many force we have here? Again, how many force? 1 force, 2 force, and 3 force. All right, 3 force we have. Now 400 we know the value, we don't know the F value. We have two unknown. So let's apply first let's apply summation of we have two unknown, right? So we need two equation. So let's apply summation of fx or summation of ax and right hand side to positive. Let's apply the horizontal if force equal to 0. So what force will come? Tell me. So 400, right? 400 is a horizontal force. Plus or minus? Tell me. Plus or minus? Plus. Right, plus. So plus 400. Then FB. Plus or minus? Tell me. FB force. FB. And horizontal force is, because this is 45 degree, so FB cos 45. Plus or minus? Plus. Thank you. Then we have RA, right? RA or FA, whatever you write down. I write down FA, doesn't matter. FA. So it is 63.74 degree and it is horizontal reaction. We write down. So cos 60.3 degree. Plus or minus? Tell me, plus or minus? Plus, right? Now look at, I think we are doing something wrong, right? What was our force here? We assume plus or minus. The not wrong, we assume what I delete it here, right? Here, sorry, here we assume the FB is upward, right? FB is upward, so I write down wrong picture here. So here FB upward, so in that case you upward, so in that case actually it will be downward. It should be, FB must have to be downward. Why it is happening? Oh sorry, is deleting everything. I don't want to delete them. It's decovering. Within this time, we do something else. So our slide, what is our slide? Lost in the slide. Okay. Yeah. Here. Okay. We got the slide. So here, so we assume the force is upward, right? So I draw it wrong. It will be in this point. It will be downward. Sorry for that, because when I draw it here. For member BD, for member BD, if we assume upward, so it must be downward. So downward, it must be downward. Okay, it must have to be downward in that case. If it is downward, so here it will be actually minus, not plus, minus 63.3 degree equal to, there is no force, so equal to 0. Assume this is equation number 1, right? So in this equation we have two unknown. We cannot find the result. We need another equation. So we can find another equation by summation of f equal to vertical to 0, summation of y or vertical to 0, and we assume upward force is positive. All right. Let's see what we have. Upward force. This is the horizontal force, so it will not come in our calculation. So we have FB, we have FB, FB, because it is downward, so it will be negative. We go downward, and this time is sine 45 degree. F minus sine 45 degree, right? Minus sine 45 degree, and we have RA, right? RA or FA, whatever there. So I put there, because it is upward, so plus FA. Now this time it is sine. This time is sine 60.3 degree, right? 60.3 degree, and there is no other forces, right? Forces equal to 0. It is equation number 2. Again we have two unknown. One is the FB and FA. So we have two equations. Solve it and tell me what is the result for FA and FB. Quickly, please. It's not working. So do it and tell me the result, please. Okay, it's not working. Can you tell me the result, please? So the result will be actually, you do it later on, check with the result with this one, 107 kilonewton. Remember kilonewton, and FB will be and FB will be 1.32 kilonewton, right? Check it and tell me if you have any question. If you have any question. Why FB is the down? Why is down? Because we assume here we assume it is upward. I tell you again, why upward? this is our member, right? Like this. This is our member, okay? Now we mix two separate things. One is like this, and one is like this. Here at B, we assume this is upward. B. So this point for equilibrium with this joint for BD member, if it is upward, for ABC member at same joint, it will be downward, right? It will be downward. Otherwise, it will be not equilibrium. You understand? So when we did the BD joint, when we assume BD, we assume it is upward, right? But when we come to the ABC lever, then we must have to assume that this is downward. This is downward. Otherwise, it will not be equilibrium. Okay. If it is, you assume here also upward, and in the lever also upward, so it will break down. It will be not equilibrium. Okay. Now, you have any question? Tell me, please. If you don't have any question, so I want to move forward. How to determine point O? The way I have determined. I show you again. The way I have determined. So how to determine? Look. How to determine? Look at me, right? So one force is 400, and another force is like this. Okay, like this, and another force is like this. How to determine? So you draw, imagine draw, and like this, and it will coincide somewhere. You must be coincide. It will coincide. There is no way like this. If it is force is like this, one force is like this, one force is like this. Okay, like this. So they will coincide somewhere. They must have to be coincide somewhere. Okay, they must have to be coincide somewhere. Okay. So here example you see, so they must have to coincide. Like this force, this was the our beam. If it is a 3-force member, they have to be coincide, right? So this is the force. Now if we want to extend like this, imagine they are extending, and then this will meet somewhere. So here meet point O. Similarly in our case, the force is, again I draw it, if you like, again I draw it. So 400 force is there, so it is there, and another force we have there, so there, and another force. Yeah, so it will coincide somewhere, and then that's how you will get it. Now question is how to draw it. Yes, the question is there's something to tell you. Why? There's important question. This is important question. Like, see, how do you extend? How do you draw? How do you draw the line? This angle. How do you draw this angle? Otherwise, you cannot draw it, right? I draw it another one. So, please understand how we will draw. Otherwise, you cannot draw. Now, here is this will be go upside. No problem. What's problem? So 400 will go horizontal. There is no confusion. With this line. But this line, how you will draw? Which angle? That's why you have to know the beginning. What is the angle? You have to know the angle. Angle is 45 degree. Angle. How we know 45 degree? From here, this is point 2, and this is also point 2. So this, if we connect these two lines, it is 45 degree angle. Okay. Then we write down it is FB is 45 degree angle. So this will be extended as 45 degree angle. 45 degree angle. Now if our things is like this, then what will happen? Like this is point 2, but this is 0.4, but this distance is 0.4. Then how will draw it? How you will draw it? You connect these two line, and tell me what is the angle? What is the angle? This angle, tell me. quickly, please. Tan theta, tan inverse, 0.2 by 0.4. What is the angle? Tell me. Can you tell me, please, what is the angle? Quickly, please. 26.5, right? Suppose 26. So the angle here 26. So here 26, right? 26 will not be like this, right? 26. Now how we will draw it? 26, right? So you have to draw it. The angle, the force is with 26 degree. 26. So draw it. So it is also 26, and then extend it. It will cross somewhere. Okay, it will cross somewhere. Then RA angle. What will the RA angle? We don't know. RA angle we don't know. So for RA, what we will do? We will do a straight up. We will connect like this, and then we will connect. We will determine theta. Okay. Now clear how to find O? Here. Okay. If you are clear, then I am to move to the next section. And maybe today we will not have time to study problem. So the last one depend on the intersection of first two. Yes, Abdullah, yes, correct. Yes, you are correct. You're trying to understand. Thank you very much. Yes, so last one will depend on the first two. Okay, yes. Right. So we will attendance is not working, the banner is not working, so forget about it. So the time we have, we cannot finish one more example, so we cannot finish. So what we'll do, we will just discuss the theory, and then next class we will finish, right? Next class hopefully we'll finish chapter 5. And someone asked me about the mid-exam question paper. It's too many. I'm working. I will work and send you. So just be patient. Also, other students also working for other courses. Okay. Now, so free body diagram. So we will learn now three in 3D free body diagram, or the in 3D system. So far we learned here 2D system. All other 2D, right? Now 3D system. This is the support system. We told you, teach you before. There is a three type of support. Right? One is called roller. We draw it like this. Another is the hinge, and another is fixed. Right? We learn it at 2D dimension. But same thing at 2D again. In 2D dimension, here will be the one how to say, here will be the one reaction, here will be the two reaction, we learn it, and here will be three reaction for 2D, fixed 3 reaction. But for 3D, suppose this one, here will be the six reaction, here will be the two reaction, and here will be the four reaction. It will be just double. Why? Because in 3D dimension we have x, y, and z. X, y, and z, right? In that case, not here will be the. So in that case, the number of reaction will increase in all direction. In number of reaction will be all direction, not 3. Here will be actually 3. Here will be the 3. I show you, right? So the number of forget about it. Number of reaction will increase. Number of reaction will increased. How increase and why increase we will show there, right? Here is the some example you see. Here is the some example we have. how here need to make bigger. When you see the book, it is much clear. You see your book. Okay, I try to make bigger. In this case, suppose this kind of support. Look, Fx, there is one moment reaction. F, why is become thicker? F y one reaction, F z other reaction. So what like this, okay? So one is the force direction, one is the moment direction, force direction, force direction. So this is you see the picture and you learn it by yourself and see already 3D dimensional picture is given there. Now, what is the reaction, right? Several example objective of the reaction is here. As example, you see here, right? Of this one, here several example object is doing the associated XYZ. I just show you one example how to determine how many reaction is there. How to determine that how many reaction in 3D system. In 3D system, as example, you see as example here is the roller, right? Here is the roller. Okay, now and you have something resting on it, like something. Okay, it will give you only horizontal vertical reaction. It will give you reaction because why? Because it is just a ball. It's just a ball. If you want to push from that side, it will go that side. It will start to move that side. If you push from this side, it will start to move that side. So it will have no reaction that, no reaction that. It will have only vertical reaction. Okay, because it is the roller. But here you will have roller. But here also same. Here how many reaction will be there? There will be the in this direction reaction, and in that direction will be reaction. Okay, but here will be in all three kind of reaction. Only there will be those reaction. Okay, so just go there and check there, right? And next class, so answer is there. Okay, and you can see the picture and can see. Now next class, and the equation is all the same. All the same, summation of 0, summation of vertical is 0, like summation of f is equal to 0, summation of f y equal to or vertical equal to 0, summation of now new formula is summation of z also 0, new thing. Similarly, summation of moment of x means here x axis will be 0, summation of y equal to 0, summation of z moment equal to 0. Okay, so these are the equilibrium equation we'll be using in next class. Right. So next class we will learn this example. Now, do you have any question? Tell me. Our time is finished. Have any question? Please. Doctor, the key answer update in BP. Which one? What is the dropping date? Tell me. What is the last date for dropping? What is the last date of dropping? Tell me. Yes, you can come. Any day 10:30. Yes, 10:30. You can come 10:30. Tell me what is dropping date? Someone asking. Okay, someone asking. Okay, fine. I will try. If is that, I will try. To the 25, right? I will try. Okay, I will try. I have to try. And what is the someone asking me? Please key answer, right? Key answer is already available. If you want, I can show you. Already you can find from the book. All point problem is from the book. Okay. This key answer means question 3 was just example. Question 3 was example, and question 2 was, I think, from a book. All from book, obviously, all from book. Key solution, you can find it easily. I think I don't need to give you especially. I tell you which one the key solution was. Doctor, I solved the test. I took 2 number after the digit. In the mid exam, there is no digit. Okay, I don't think that will be problem. Kamal Ashraf, I don't know. I will check it. Okay, I will check. So 358, page number 111. This problem, I think you can find it in solution. But if you don't have, you can ask me, right? You can guess it. Question 3 was what is your office number? 2076. Abdullah Muhammad and Abdullah, you wrote something Arabic. I don't know Arabic. I don't understand. You want to tell me something, write in English. No, today you cannot. Today I haven't finished. Okay. I will try to finish your marks and I will give you. After that, if you have any complaint, then you can come to my office. My office to near Engineer Jihad office. Yes. That's next one. Any question, please? Any other question, please? If you have no question, then I want to actually leave the session. I want to close the session. Please. Thanks. You're welcome. So